Okay, so if we have a uniform angular velocity or even some given angular velocity, you can't, well, for any rotating object, you don't have uniform speeds of those objects. Objects that are closer to the axis are not moving as fast as objects that are far from the axis at any given angular velocity, right? Okay, now, how do we get the speed at, let's say, distance r from the axis if we're given the angular velocity? Okay? So let's just make sure we understand what angular velocity is. It's kind of a new concept. So, angular velocity is the rate of change of angular position. Omega equals d theta dt. Now we've defined this, but you haven't had an assignment that makes you really retrieve that. Okay? And we've analyzed the trapezoid, right? For both angular and linear velocities, right? What's the area of this trapezoid tell you? What's the slope of this trapezoid tell you?
The angular velocity.
Which tells you the angular velocity?
What?
What tells you the angular velocity?
Oh, I meant the angular acceleration from the slope.
Yeah, the slope is the angular acceleration, and the change in angular position, the delta theta, is the area within here. Okay? You want to be sure that you go over this. You should really draw these trapezoids for both velocities and angular velocities at least once a day. Figure out what the area and the slope is, what it means. Make sure you understand what the rise between 2 points mean, the run, why the slope means what it does, what the average altitude of this trapezoid is, and why then the area of the trapezoid is what it is. Something you just have to lock in. Okay, we've been at this over 2 weeks. That was one of the first things we saw. You need to lock it in now. Okay? So, anyhow, just refreshing your memory on something that you want to lock in, right? Okay? Lock all this in. By all this, I don't mean just what's on the board here. I mean the whole picture of a trapezoid. Okay? And all the equations and everything. Okay, well, anyhow. Okay, that's what angular velocity is. What's a typical calculation of angular velocity?